Now we are going to study question from March 2011 exam, question 3. Everyone give the heading March 2011 question 3. Okay. Everyone please give the heading March 2011 question 3. Now everyone try to see the scenario, what the question want to say. I am going to read the question with you guys. So two masses are suspended by a light cord. Two masses are suspended by a light cord from a light smooth movable pulley. See, here we have two pulleys in this question. One pulley is movable, another one is fixed one. So two masses are suspended by a light cord from a light smooth movable pulley. The movable pulley is suspended over a, see, the movable pulley is what? Guys, what is the movable pulley? Is suspended over a fixed pulley, fixed light smooth pulley. See what they are saying? Smooth pulleys, movable pulley is also smooth, and another pulley is what? Fixed smooth pulley by a light cord with a mass of 7 kg attached to the other end of the cord as shown in figure question 3. Why they are saying figure question 3? Because in that exam it is question 3. The masses are released from a rest. The masses are then released from the rest position. Okay, initial velocity of these masses is what? 0. Now try to see the scenario. What is the here, guys? So this is what our fixed pulley. Guys, try to observe the scenario here. Very simple discussion, not that much difficult. So here what we have? This is what? This is what, guys? This pulley is what? What pulley? This one? Fixed pulley. So this is what our fixed pulley. Try to observe the scenario. So this is what a fixed pulley. Then on one side of the fixed pulley, what we have? On one side of this fixed pulley, what we have? On one side of fixed pulley, what we have, guys? So this is what a 7 kg mass. And on another side of this pulley, what we have, guys? On another side of this one, what we have, guys? Movable pulley. Okay. So this is what our movable pulley. Everyone try to observe the scenario. So this is what a movable pulley. On one side of movable pulley, what we have? This is what, guys? This is what a 1 kg mass. And on another side, what we have? This is what on another side? 2 kg or 3 kg, guys? 3 kg mass. Okay, try to observe the scenario. It is a 3 kg. Okay, so I am again reading the question. So two masses are suspended by a light cord from a light smooth movable pulley. Okay, so see, two masses. On this is what? This pulley is what, guys? What is this pulley? This pulley is what? This pulley is what? Movable pulley. Let's try to see the scenario. This is what our movable pulley. Okay, everyone getting my point? Anyone have any doubt in this discussion? So this is what our movable pulley. And this pulley is what? This pulley is what? Everyone? Fixed pulley. And both pulleys are, what is the speciality of both pulleys, guys? Both are smooth. Okay. Okay. Smooth fixed pulley. And here we can say smooth movable pulley. Whenever they are saying smooth, what does it mean, guys? What is the meaning of word smooth? Whenever there is a smooth, guys, what is the meaning of word smooth? Smooth means what? What is the meaning of smooth? Frictionless. So tension on both sides will be same. Okay. Whenever in the question they said smooth, it means there is no rotation of these pulleys. Tension on both sides will be same. See, after this chapter, we are going to study next chapter is a rotational motion. In that scenario, tension in both sides is not same. Okay. Let's try to see the scenario here. Now, what they are asking us here, the masses are then released from a rest position. Okay, suppose this initially, assume that these masses are on some platform. Okay, and we are going to release that masses. Okay, now try to see the point here. Now what they are asking us in the A part. In A part, what they are asking us, we have to calculate the acceleration of this 7 kg mass. What is our target in A part? What is our target in A part? What we have to find out? Acceleration of what? Of 7 kg mass. That is what our target in A part. Try to see the scenario here, everyone. This is what our target in A part. This is what our target in A part. Now how to deal with this A part scenario? Okay, very simple scenario guys. In A part, we have to find out acceleration of this 7 kg mass. Now guys, what they are saying in the question, there is one word. Two masses are suspended by a light cord from a light, smooth, movable pulley. So what they are saying, this movable pulley is what guys? Light. Whenever they are saying word light, okay, in the question what they said? A light, smooth, movable pulley. See the word guys, everyone. A light, smooth, movable pulley. So in the question, whenever they say light pulley, it means what? Mass of the pulley is negligible. Okay, whenever they are saying light pulley, it means what guys? Mass of that pulley is what? Negligible. So here two words related with pulley. First word light pulley means mass negligible. Second one smooth pulley means what? Friction is zero. So tension on both sides will be same. Okay guys, try to see the scenario. So in A part, what is our target? We have to find out acceleration of 7 kg mass. That is what our target in A part. Now see, these pulleys are what? Light pulley. So the masses of the pulleys is negligible. Now see, so what will be the total mass of this movable pulley then? What will be the total mass on this side? So on this side we have a mass of 7 kg. On this side what we have guys? 3 plus 1, 4 kg. Means can we consider this complete arrangement as a single mass guys? Means this 7 kg mass will go down and this movable pulley arrangement will go up. See, whenever we are releasing this system, release from a rest, suppose initially this system is on some platform, and if you remove that platform, what will happen? If you remove that platform, what will happen guys? If you remove that platform, what will happen? The masses will start move, means 7 kg will start move downward and this movable pulley arrangement will go up. Okay guys, are you getting my point? Try to see the scenario. So can we consider this entire arrangement as a single mass? This entire arrangement means what? This movable pulley will not have any mass because it is a light pulley. In the question they have mentioned. Guys, are you getting my point? So try to see the scenario here. So this entire arrangement of this movable pulley can be considered as a single mass. And what will be that single mass? What will be that mass then? What will be this mass? 4 kg. So now try to see the scenario. Very simple discussion guys. Considering movable pulley arrangement as a single mass. Okay, what we are going to do, what we are going to consider, we are going to consider this movable pulley arrangement as a single mass. Considering movable pulley, everyone try to see the scenario. Movable pulley arrangement, very simple discussion guys. Movable pulley arrangement as a what guys? As a single mass. Okay, that is what we are going to consider. Considering movable pulley arrangement as a what guys? As a single mass. Try to see the scenario here. So what we are going to do? So this is what our guys fixed pulley. Everyone, this is what a fixed. Fixed means what? It is not moving. Pulley is not moving. Okay. On one side what we have? On this fixed pulley. On one side what we have guys? On this fixed pulley what we have? On one side what we have? Mass of 7 kg. And on another side we have a, so considering movable pulley arrangement as a single mass. Okay, so here this movable pulley arrangement will become how much mass? 4 kg. So on this side we have a mass of what guys? On this side what we have? We have a mass of what? 4 kg. Now this pulley is what? So this is what our, so what is meant by this 4 kg mass? 4 kg mass is what? Is a representation for this movable pulley arrangement. Now the next point is what? What about the motion of the 7 kg mass? Motion of the 7 kg mass is what? Downward. Its acceleration A. Motion of the 4 kg mass is what? Upward. It will have also, means 4 kg mass also have acceleration. What is acceleration 4 kg mass has? Same acceleration A, because they are on the same radius. Now this pulley is what guys? This is what? A smooth pulley. A pulley is smooth, what we can say? Tension on both sides will be what guys? Tension on both sides will be what? Same. So this is tension F. And on this side is also what we can say? On this side also what we can say? Tension is what? We can say F. This side weight is how much guys? This side weight is how much? 4g. And here this side weight is how much? 7g. And what we have to find out in A part, what is our target? We have to find out the value of A. Okay guys, are you getting my point? Now try to see the scenario here. Okay, anyone have any doubt in this drawing? Very simple discussion guys, huh? Anyone have any doubt in this discussion? Please try to see the scenario here. Now the next point is what guys? What is the next point here? What is the next point, everyone? Okay. So what will be the next point? What we are going to consider? We are going to consider first of all 7 kg mass. You can consider 4 kg mass, no problem. So for 7 kg mass, everyone try to see the scenario. For 7 kg mass, everyone observe the things, very simple discussion. For 7 kg mass, what will be the scenario for the 7 kg mass? Summation of, we can apply Newton's second law of motion. So for 7 kg mass, Newton's second law of motion, summation of force is equal to what guys? Yame? Summation of force. Forces in the direction of motion we can consider as a positive, and opposite forces what we can consider? Opposite forces we can consider negative. So what are the forces here in the direction of motion here? For the 7 kg mass, discussion is going for the 7 kg mass guys. So what are the forces in the direction of motion here? 7g, okay, good. Then what about next force guys? Minus F is equal to what guys? 7a. So F will become what? F will become what? 7g minus 7a. Guys, observe the scenario. Huh? Everyone, please be careful. If I have done any mistake, please let me know. Sometimes, not sometimes, many times, I may do a mistakes like that. So you have to be attentive in the class, everyone. So F is equal to 7g minus 7a. So what we can say? This is what? Equation 1. Now same, in the similar scenario, we can consider what we can consider guys? For 7 kg mass, instead of that what we can consider? For 4 kg mass, what we can consider? For 4 kg mass. So what is the scenario for the 4 kg mass guys? What is the scenario for 4 kg mass? Summation of F is equal to what? Yame, Newton's second law of motion. We are going to apply Newton's second law of motion. Now, forces in the direction of motion considered as positive and opposite forces negative. What are the forces here in the direction of motion? What are the forces here for the 4 kg mass? Two forces are acting on the 4 kg mass. One is F, second one is 4g. What are the forces here guys? What are the forces? F, another force, minus 4g is equal to what guys? What is the value of mass? 4 into acceleration. So F will become equal to what guys? 4a plus 4g. Okay, and this is what our equation 2. Very simple scenario guys. Now what is our target here? We have to find out what? Acceleration. This acceleration we have to find out. Now to get the acceleration, what we are going to do? We are going to see, if you observe this equation 1 and 2, observe this equation 1. Everyone observe this equation 1. This is what our equation 1 and this is what our equation 2. So if you observe both the equation, what is the speciality? What is the common between these two equations? Left hand side of both the equation. What is common between these two equations guys? Left hand side of these two equations. If the left hand side is same, what we can say according to mathematically? If left hand side is same, LHS is same, then by default right hand side will also same. Okay guys, are you getting my point? So if we equate these two equations, what we will get? If we equate these two equations, what we will get? We will get the value of acceleration. Okay guys, are you getting my point? Try to see the scenario here, everyone. So before going further, what we have to do? First of all, give the heading of the question properly. Then try to draw this drawing. Then write down the target of the A part. We have to find out acceleration of 7 kg mass. After that, write down this point. Considering movable pulley arrangement as a single mass. Then draw this drawing. Beside this drawing, start writing down equation 1 and 2. Okay. Write down properly everyone. In mechanics, means in every technical subject, your notes must be in proper format. So please everyone, write down all these points. Now guys, try to see the scenario here. What is our target? We have to find out acceleration. So for getting acceleration, what we are going to do? For getting acceleration, what we are going to do? On equating equation 1 and 2, what we are going to do? On equating, what we are going to do? On equating equation 1 and 2. Okay. So on equating equation 1 and 2, 7g minus 7a is equal to what we can write? 4a plus 4g. So please everyone try to see the scenario. So 7g minus 4g is equal to 4a plus 7a. Everyone observe the things. Please let me know if I have done any mistake. So 3g is equal to what guys? 11a, 4 plus 7, 7 minus 4. So acceleration is equal to what? 3 into 9.81 divided by what guys? 11. So please everyone do the calculation and tell me the value of a. Everyone tell me the value of a. So 3 into 9.81 divided by what guys? 11. How much guys value we are getting? 2.6755 meter per second square. Everyone try to see the scenario here. So this is what our answer of A. That is what they are asking us in A part. Acceleration of 7 kg mass. Please everyone write down this one. Now guys, try to read the B part here carefully. What they are asking us in the B part? Tension in each chord. Okay. So how many chords with us here? 2 chords here with us. First chord is connecting movable pulley and 7 kg mass, and another chord is what? Second chord is connecting 3 kg mass and 1 kg mass. So here we have what guys? What we have? We have a 2 chords. Okay. Everyone try to see the scenario here. Now what they are asking us in this scenario? Tension in each chord. Okay, what they are asking us here? Tension in each chord. So first of all guys, in A part what they are asking us? Sorry, in B part, tension in each chord. And how many chords with us here? We have a 2 chords. One chord is connecting movable pulley and 7 kg mass, and another connecting 3 kg mass and 1 kg mass. So here we have a 2 chords. Okay. So first of all guys, so what is this here? This F is what? Tension in which chord guys? This F, what is this expression of F we got? This is a tension in which chord? Tension in the chord guys what? See, this 4 kg mass we consider as a what? What we consider this 4 kg mass? Is a movable pulley arrangement. So whatever the mass connect means this chord. So this side 7 kg, this side 4 kg. So the tension in this chord will be this F, either from this expression or this expression. So guys, so what we are going to do? So in A part what they are asking us, sorry, in B part what they are asking us? Tension in each chord. Tension in each chord. Okay, everyone try to see the scenario here. So we are going to substitute. We have just now we calculated few minutes before. We are going to substitute value of A. What guys? A stand for acceleration. In equation 1 we are going to substitute value of A. So we will get the value of force F. F is what? 7g minus 7a. So this is what our equation 1. Everyone. So F will be equal to what? 7 into 9.81 minus 7 into how much? Guys, acceleration 2.6755. Everyone. So what will be the value of F guys? Everyone please do the calculation. 7 multiplied by what? 7 multiplied by 9.81 minus 7 multiplied by what? 2.6755. How much guys value we are getting? 49.9415. Okay, unit Newton. And this tension is what? Tension in which chord guys? So therefore tension in the chord at the end, concluding statement. So tension in the chord what? Connecting what guys? Connecting 7 kg mass and movable pulley. Okay, everyone try to see the scenario. Is what guys? How much guys? 49.9415 Newton. So this is what one of, there are two answers. Here in B part we have to find out two answers. Out of that we got the one answer, tension in the cord connecting 7 kg mass and movable pulley. Anyone have any doubt in this discussion guys? Please check it. If I have done any calculation mistake or not, always check it, everyone. Okay, everyone, anyone have any doubt in this discussion? So please everyone write down the first of all target and please write down all this point carefully. Everyone, please write down. Now try to see the scenario. What is our next point here? What is here next point? What we have to find out? We have to find out tension in the cord connecting 3 kg mass and 1 kg mass. That is what we have to find out here guys. Okay, everyone try to see the scenario. Now how we are going to find out 3 kg mass and 1 kg mass tension in the cord connecting them? So for that purpose what we are going to consider? We are going to consider one imaginary support here. What we are going to consider here? We are going to add one imaginary support here. This will be what guys? Everyone, this is visible to everyone. So this will be what? This support will be what guys? What is this support? Imaginary support. Just assume that, what we will assume? We are going to assume this movable pulley as a fixed pulley. So what we are going to consider? Considering movable pulley as a fixed one. So what we are going to consider? Considering, everyone try to see the scenario, considering movable pulley as fixed. Just for a moment, what we are going to consider, just imagine that this movable pulley is what we are going to consider fixed. Now for that purpose what we are going to do? So this is what our movable pulley. Everyone try to see the scenario. This is what our movable pulley. Then what we have? This is a movable pulley. This is what? This support is what guys? This support is what? Our imaginary support. This support is what everyone? Imaginary support. On one side, this side, which mass we have guys? On this side, which mass we have? 1 kg mass. And on another side, which mass we have? 3 kg mass. So this side we have a 3 kg mass. Now, so try to see the scenario. Tensions here what guys? Here we assume tension as what? F1. Here what we assume? Tension as a F1. And here what we assume? What we assume? Here tension as a F1. Both side tension will be same because a smooth pulley is here. Here weight is how much? 3G. Here weight is how much guys? 1G. Okay. Or simply no need to write 1G. So directly we can write is G. 1G means directly G. So now here motion is how? See, if you consider this as an imaginary support, we assume this movable pulley as a fixed one. So what will happen guys if you assume that movable pulley as fixed one? Then what will be the scenario? So this 3 kg mass will go down. So this is its motion. And it is acceleration. We will say acceleration A1. And here this motion is what guys? Upward. And here what we can assume? Acceleration as a A1. Okay, everyone try to see the scenario. Very, very important discussion. Now try to see the point here, everyone. So first of all, we will consider for 3 kg mass. Everyone observe the things. For 3 kg mass, first of all, what we consider? For 3 kg mass. Okay, or instead of this one, I will use this one. So for 3 kg mass, what will be 3 kg mass guys? What will be 3 kg mass? For 3 kg mass, okay, 1 minute, I am going to write down properly. So for 3 kg mass, everyone, we are going to apply Newton's second law of motion. Summation of force is equal to what? For 3 kg mass, summation of force is equal to what? Summation of force is equal to what? MA. What are the forces here guys? So summation of F is equal to what? MA. What are the forces here? What are the forces here? Force in the direction of motion positive, opposite is negative. What is force here in the direction of motion here? 3g. So 3g minus what guys? F1 is equal to what? 3 acceleration we considered as a A1. Here we consider acceleration as a A1 because in earlier scenario we consider acceleration as a. So if we assume this as an imaginary support, means we have assumed this movable pulley as a fixed one, then we consider acceleration as A1. Here also acceleration as A1 and tension on both sides is what? We consider as a F1. Okay. Now what we can say? F1 is equal to what we can say? 3g minus 3a1. Okay. And we will consider this as our equation number 3 because we already considered equation 1 and 2 previously in A part. Now then what is the next point here? Then we are going to consider for what guys? What we are going to consider for next one is what? For 1 kg mass. Again we are going to apply for 1 kg mass. What we are going to apply? We are going to apply Newton's second law of motion. What we are going to apply? Newton's second law of motion. What is Newton's second law of motion says? Summation of force is equal to what? Mass into acceleration. Everyone try to see the scenario. There are different forms of Newton's second law. Different statements are there. But the useful statement for us, summation of force is equal to net force on the object is equal to mass into acceleration. So summation of F is equal to what guys? Ma. So what are the forces here in the direction of motion? F1 positive minus g. Basically it is 1g. But 1g or g, it is the same meaning because for every time if nothing is there, it means its previous term is what? Coefficient is what? 1. So 1g is equal to what guys? 1 into a, everyone. So F1 is equal to what guys? A, we will say A1 plus g, and we are going to say it as a equation number, what we will say? Equation number 4. Now if you observe this equation 3 and 4, what will come to know that? If you observe this equation 3 and 4, what is come to know that? If you observe this equation 3 and 4, what is come to know that? For both the equations, which side is same here? Left hand side is same. Here F1 and here is also what guys? Here is F1 and here is also F1. If you equate these two one, means if your left hand side is same, by default right hand side will also same. So what is the statement we will write? From equating equation 3 and 4, everyone try to see the scenario. From equating what guys? From equating what? Equation 3 and 4. What is equation 3 says? What is equation 3 says guys? What is equation 3 say? 3g minus 3a1 is equal to what guys? A1 plus g. Everyone try to observe the scenario. So 3g minus g is equal to a1 plus 3a1. Okay. So this will become 2g is equal to what guys? Everyone, is it 2g is equal to what? 4a1. So what will be the value of acceleration? 2 multiplied by 9.81 divided by what? 2. So here we will get the value of acceleration. Everyone do the calculation and tell me the value of acceleration. Which one? 3g minus. Okay. Yes. Here it will come 4. Okay, good. So please everyone, very good. 2 into 9.81 divided by what guys? 4. So what is the value of A1 we are getting? 4.905 meter per second square. Okay. This is the value of acceleration of 3 kg mass and 1 kg mass if you assume this support as an imaginary, means if you consider movable pulley as a fixed one. So first of all guys, everyone please write down this part, after this part. Then we will see how to find out the tension. This F1 is not our answer. We have to do some more calculation. This F1 is not our answer of another answer of B part. Other answer of B part, this F1 is not other answer. Okay. We have to add something in that F1 and that will be our answer. Everyone try to see the point here. Please everyone write down this one. Okay. First of all this, after that this one. Now try to, now try to see the scenario here. What we have to find out? What we have to find out? Means tension in the cord connecting 3 kg mass and 1 kg mass. Okay. For that purpose, what we are going to do? For that purpose, what we are going to do? Everyone try to see the scenario. Very simple thing. So in one cord we already calculated the tension. We have to calculate tension in the other cord. So we are going to substitute value of A1. Everyone substitute value of A1 in what? Equation 3. So what is equation 3, guys? What is equation 3? F1 is equal to what? A1 plus G. So F1 is equal to what? What is the A1? 4.905. G is what? 9.81. So what will be the value of F1, everyone? 5, 1. How much, guys? 14.715. Check it, guys. Check it, everyone. Is it okay? Okay. 14.715 Newton. So we got F1. But F1 is not our answer. See, guys. F1 is the tension in the cord when this movable pulley is what? Not moving. This F1 is the tension in the cord when this movable pulley is not moving. But actually, what is the scenario, guys? Actually, what is the scenario? This movable pulley is what? This movable pulley is what? Moving. And which force is responsible for that movable pulley movement? This F. Here what we have, guys? F. Everyone. Here what we have, a F. If this F is means pulling that one, guys, automatically this will come in. This F will come into this masses. So what we can say? So therefore, try to see the scenario. Therefore, tension in the cord. Therefore, tension in the cord connecting what, guys? Tension in the cord connecting what? Tension in the cord connecting 3 kg mass and what? And 1 kg mass. Okay. So what will be that point? Tension in the cord connecting 3 kg mass. So if this movable pulley is stationary, tension will be what, guys? F1. But actually this movable pulley is what? Moving. So F1 is there. And which force is responsible for that movement? F. So tension will be what, guys, here? F1 plus F. You got this point, guys. You got this point. F1 plus F. Everyone. Try to see the scenario here. Means see. If this movable pulley is what, guys? If this movable pulley is what? If this movable pulley is what? Not moving. Then tension is what? F1. But actually this movable pulley is what? Moving. And which force is responsible for the movement? F. Which force is what responsible for the movement? F. So F1 is when this scenario is stationary. But if it is moving, then what will have? Which is responsible for the movement? F is responsible for the movement. So F1 due to stationary scenario and F is for the moving scenario. So overall effect will be what, guys? F1 plus F. Okay, guys, are you getting my point? Try to see the scenario here. Everyone. So what is the value of F1? 14.715. What is the value of F, guys? What is the value of F? F1 value is 14 point. How much, guys? 9415. Okay, good. So please everyone do the calculation. So in this way we will get the another answer of the P part. Okay, please everyone calculate this one. Always do calculation. How much? 64.65 unit, guys. Newton. Why it is Newton? Because tension is a force. So this is another answer of our B part. Guys, everyone got this F1 plus F? Everyone? Your doubt is what, sir? Why we are getting two tensions? See, the pulleys are different now here. Means this F1 is in which scenario? This F1 in which scenario? For this one. For this cord. For this pulley. And initial F is for what? Initial F is for what? This cord. Nah? Are you getting my point? See the scenario. See, if you consider this F1 means here this F. Here also F na. For on this 7 kg we have a F. So means I'm not getting your point, sir. So see, it is same na, sir. For the given chord it is the same. When chord is changing, then tension is different. Here see, here is F, here is also F, but here chord is different, na sir. Okay, guys, are you getting my point? Try to see the scenario. Means your doubt is what? What is your doubt? Your doubt is what? Sir, here tension must be same. But tension must be same in which scenario? When chord is same, na? For the smooth pulley, same chord. But here, see, here we have a F, here also we have a F because same chord. But here, see this one. For this pulley, chord is changing. If chord is changing, then tension will also change. See, but see, if you observe this one, this is another chord now. But here, if you observe these masses, if these masses are stationary, if these masses, see, basically, see, suppose in the, means basically this pulley is moving, along with pulley, with respect to pulley, there is a movement of this 3 kg and 1 kg masses. With respect to, means if this pulley is moving, and with respect to pulley, there is a movement of 3 kg mass and 1 kg mass is also. So that's why here we are getting some extra tension. Means here we have a F also and there is a F1. And F1 is what? Means with respect to this one, with respect to this 3 kg and 1 kg mass, we have a F1 is also there. With respect to means there is a, okay, are you getting my point? Try to think on this more because this point maybe I feel difficult to explain sometimes. Movement of this 3 kg mass and 1 kg mass. Okay, with respect to this movable pulley. Okay, everyone please write down this one. Now the next part is quite interesting, guys. That is the extra part. What is the extra part I have given to you? Acceleration of 3 kg mass and 1 kg mass. Okay. Now guys, I am going to give you one best example of escalator in the mall, shopping malls. Nowadays, there are big shopping malls in India, big shopping malls. If you visited Mumbai, there are some huge, in every big cities, we have a shopping malls. So what is the scenario here? Try to observe the things here, everyone. Don't write anything, don't do anything. So what is extra part? Acceleration of what? 7 kg mass and acceleration of 3 kg mass. Now, just observe the things here. Before the lockdown, I visited one mall for watching movie, okay? Okay, I visited one mall means for watching movie and to do some shopping, okay? Now, see the point here. So, our C part is what? Acceleration of, first of all, I am going to calculate acceleration of 1 kg mass, okay? Acceleration of 1 kg mass, okay? First point, I am going to calculate acceleration of 1 kg mass. Before calculating acceleration of 1 kg mass, I am going to give one example of escalator where I am riding in that escalator, okay? See, this is what a escalator, okay? Moving stairs. This is what a escalator, suppose. This is what a escalator. Now, initially, suppose assume that this escalator is what? A stationary. Just assume that this escalator is not moving, these moving stairs are not moving, and here I am standing. Here I am standing, and in this scenario, I am moving with, okay, see, I am moving, I am going up, and here this escalator is not moving, huh? This escalator is not moving. This escalator is not moving. So when the escalator is not moving, I will go. So sometimes the escalator is not working, so in bad situation. So there is some problem in escalator, so because of that it is not moving. But in that scenario, suppose my velocity is what? When escalator is not moving, suppose my velocity is what? 2 meter per second. My velocity is what, guys? 2 meters per second, and this escalator is what? Escalator is not moving. Now what is meant by escalator is not moving? What is the meaning of 2 meters per second when escalator? We have not studied relative velocity chapter, okay? But in relative velocity we will study these things more in detailed way. It means this is my velocity of Yogesh with respect to escalator. Okay, guys, I am giving you example of velocity because it is easy to understand. Escalator. Okay, everyone, are you getting my point? So this is what? 2 meter per second velocity of Yogesh with respect to escalator. With respect to escalator means what? Escalator is not moving. Now just assume that now in the next scenario escalator is moving. This escalator is what, guys? This escalator is moving with velocity of escalator is what? 1 meter per second. What is the velocity of work? What is the velocity of escalator? 1 meter. In initial situation, escalator is not moving, and in that scenario my velocity is 2 meter per second. So we can say it as a velocity of Yogesh with respect to escalator. Because in that scenario, with respect to means what? We can assume that situation as a stationary. So we assume this escalator is not moving. So if escalator is not moving, then my velocity is what? 2 meter per second. Now suddenly escalator, suppose I reach somewhere in between, and suddenly escalator started with a velocity of 1 meter per second. Then what will be my velocity, net velocity? What will be the net velocity of Yogesh then? My initial velocity is 2 meter, and then there will be what, guys? Escalator started moving. So what will be my net velocity in that scenario? What will be the net? 3 meter per second. Okay. With respect to escalator, my velocity is 2, and escalator is moving with 1 meter. So what will be the next point? So my total velocity will be what? Total velocity of Yogesh will be what, guys? 3 meter per second. You got this point? Everyone getting my point? Try to see the scenario here. Now why I am explaining you example of escalator? Because the same situation is here also. Suppose this movable pulley is not moving. This movable pulley is what, guys? Suppose it is not moving. Then what will be the acceleration of 1 kg mass? What is the acceleration of 1 kg mass? A1. So this movable pulley is not moving, then acceleration of 1 kg mass is what? A1, and it is upward. Just now we calculated, guys. If this movable pulley is not moving, then acceleration of 1 kg mass is A1 and it is upward direction. But actually what is happening? This movable pulley is moving with a velocity, with the acceleration of what? A. So what will be the total acceleration of 1 kg mass then? Movable pulley is also moving. With respect to movable pulley, 1 kg is also moving upward. Okay. Movable pulley is moving upward. This 1 kg mass is moving upward with respect to this. This 1 kg mass is moving upward with respect to movable pulley. So what will be the, guys, total acceleration of the 1 kg mass? What will be the acceleration of the 1 kg mass then? If No, it is not a minus now. Both are moving. See, with respect to yes, means if, guys, correct. See, if this movable pulley is stationary, then acceleration is what, guys? A1. If this movable pulley is not moving, if you assume this stationary, then acceleration of 1 kg mass is what? A1. But actually what is happened here, guys? What is happened, guys? This movable pulley is going what, guys? Movable pulley is moving, and what is the acceleration of movable pulley, guys? What is the acceleration we calculated for the movable pulley? A. So here acceleration is what? A1 plus A. The same example here with means not moving, then velocity is what? 2 meter per second. Escalator is moving with velocity of 1 meter per second. So what will be the total velocity of the person which is moving on the escalator, on the moving escalator? 3 meter per second, 2 plus 1. The same scenario is here also. Okay, guys, you got this point, everyone? Anyone have any doubt in this discussion? Now guys, another point. Now another scenario. Now here another scenario. Sometimes in movies, guys, we observe, means someone, see, suppose one person want to go down. Okay, everyone. Anyone have any doubt in this expression? Acceleration of 1 kg mass. Anyone have any doubt in this acceleration of 1 kg mass? Oh, okay, good. Why it is A1 plus A? Because A1 means what? With respect to, what is the meaning of A1? What is the meaning of A1, guys? With respect to acceleration of 1 kg mass with respect to what, guys? With respect to movable pulley. And this is what the acceleration of what, guys? What is meant by this one? What is meant by this one, guys? Acceleration of movable pulley. Okay, and both are in the same direction. Okay guys, are you getting my point? Try to see the scenario here. Anyone have any doubt in this discussion? Means consider an example of bus. Okay, suppose one bus is there. On the bus, one person is moving. Suppose bus is stationary, one person is moving. Suppose bus conductor is moving. Okay, for the ticket. He's saying bus conductor is moving even the bus is stationary. When bus started moving, what will happen? Okay, suppose person velocity is what? 5 km per hour. That person on the bus, which is when bus is stationary, the conductor velocity is what? 5 km per hour. When bus started moving, bus velocity is what? 40 km per hour. Then what will be the total velocity of this bus conductor? 5 plus 40. Okay guys, are you getting my point? Means 45 km per hour. The same scenario is here also. Okay, so here we got the acceleration of 1 kg mass. In this way, A1 plus A. Now what about 3 kg mass, guys? What about 3 kg mass? Now I am going to explain you another example of our escalator. Okay, try to see the scenario. Suppose I am in hurry, or in one of the movies. Okay, if you observe the movies, in many movies they will say, means this is what our escalator. Okay guys, this is what escalator, moving stairs. Now suppose these stairs are not moving. When stairs are not moving, velocity of Yogesh with respect to escalator is what? When stairs are not moving, velocity is what? 3 meter per second. Okay, and this Yogesh is going what, guys? Yogesh is going down. Okay, in this scenario, Yogesh is what? What is Yogesh is doing? Yogesh is going down. Okay, suddenly what happened? Escalator started. But in this scenario, the escalator is not going down. Escalator is what? Going up, and velocity of escalator is what? 1 meter per second. So now what is the net velocity of the Yogesh, guys, in this scenario? What is the actual velocity of Yogesh when it is going down on the escalator? If escalator is stationary, velocity is what? 3 meter per second. And Yogesh is going down. And when escalator started, velocity of escalator is what? 1 meter per second. So what will be the velocity of Yogesh, guys? What is the absolute velocity of Yogesh when escalator started moving? 2. How we got 2? And 2 in downward direction, everyone. Okay, in this way. So 3 minus 1. So same scenario here with respect to what, guys? With respect to 3 kg mass. See, when this movable pulley, guys, try to see the scenario. Acceleration of what, guys? Acceleration of what, everyone? Acceleration of what? Acceleration of 3 kg mass, everyone. So acceleration of 3 kg mass will become what, guys? When this movable pulley is not moving, acceleration of 3 kg mass is what? A1, and it is in downward direction. When it is not moving, A1. But actually this movable pulley is doing what, guys? This movable pulley, is it stationary? It is going up. With which acceleration it is going up? With the acceleration of A. So A1 downward with respect to movable pulley, and movable pulley is what? Going up. So what will be the acceleration of 3 kg mass, guys? A1 minus A. And why A1 minus A, guys? Why A1 minus A? Everyone, because it is in downward direction, A is in upward direction, okay, and here y plus A1 upward and A is also upward. Okay guys, are you getting my point? Try to see the scenario here. Okay, so what is the value of A1? What is the value of A1 guys? What is the value of A1? 4.905 minus, what is the value of A? 2.6755. So please everyone do the calculation and we will get the acceleration of 3 kg mass in this way. 4.905. Okay everyone, please try to see the scenario. Very important discussion guys. How much guys? 2.2295 meter per second square acceleration. And here what we will have guys for this scenario? Acceleration of A1 is how much guys? 4.905 everyone plus 2.6755. Okay, please do the calculation. Okay, how much guys? 7.5805 meter per second square. Okay guys, are you getting my point? So this is what our acceleration of, this is what acceleration of what guys? 1 kg mass. This is what acceleration of, this is what acceleration of 1 kg mass. This is acceleration of 3 kg mass. Okay, here acceleration, we are getting acceleration of 1 kg mass higher because here with respect to movable pulley upward, and movable pulley acceleration is also upward, more upward. A1 is downward. Guys, are you getting my point? Everyone? Anyone have any doubt this one? So here direction is upward and here direction is what? Downward. Okay. Everyone, please everyone write down this one. This is the extra part, acceleration of 1 kg mass and acceleration of 3 kg mass. Please everyone write down.